Okay, so finally you're streaming. Today we'll be discussing about quant inequalities. What we have done in the last all these study sessions is we took some 25 questions which are actually difficult, and then those questions we tried to solve all of them because there are a lot of traps. Those are called like C trap and various DS traps. So now what we will do, we'll try to solve it the questions based on the topics so that with like 4 or 5 quant sessions we'll be trying to cover mostly all the topics that are present. So right, let me cover that. So this is some concepts we'll be discussing. So this is kind of session 2, we say whatever you want to say. So let's see some key concepts. We'll brush them fast and then we'll start doing the questions. So first concept is, okay, if it says that if a is greater than b, then you cannot multiply it with some number, which is m here, uh, unless you know the sign. So, like it says, if a is greater than b, then am is greater than bm, and if m is that's only when m is greater than 0, and am is less than bm when m is less than 0. What it says is, like, if a is greater than b is given, we cannot say like am is greater than bm always. It can also be am is less than bm. When this happens, so whenever we want to cross multiply in an inequality, we should always know the sign of the multiplier. Why I say so is, suppose we take a as 3 and b as 2, where it satisfies 3 is greater than 2. Now when m is positive, suppose it is 1, then it multiplies it with 3 into 1, which will be 3, and 2 into 1, which will be 2, which is fine, right? We get 3 and 2. But what happens with m is negative? So when m is negative, it will become 3 into minus 1 greater than 2 into minus 1, right? That will make minus 3 greater than minus 2. But in real world, this is wrong, right? So whenever there is a minus sign, we actually switch this operator. So whenever we multiply a minus a negative number, we'll be switching the sign, and whenever we multiply a positive number, we'll keep the sign. So that's what this is. A is greater than b if a, then am is greater than bm for m is greater than 0, that means m is positive, and am is less than bm, that means the sign is switched when m is negative. That is when we multiply both the sides of the inequality by this by a negative quantity, the sign of the inequality is reversed. And do not cancel anything from both the sides of the inequality unless you're sure that the cancel quantity is positive. Again, this is the same logic, but this is not for adding but for cancelling. Like what they say is ax is greater than ay, so we cannot cancel uh, this a on both the sides because it will make it x is greater than y always. Because this, though it looks very simple, why we cannot cancel, but this is very tricky. What happens if a is negative? So when a is positive, suppose a is 1, then we get x is greater than y. But what happens when a is minus 1? Then it will be minus x greater than minus y, which is actually now not that good, because suppose x, so again I will take 3 and y was 2, right? So then it will make it minus 3 greater than minus 2, which is wrong. So we can only cancel only when we know the sign. Either if both of them are negative and we know the sign, then we cancel them and switch the sign. Okay. Also, it says don't cross multiply unless you are sure of the sign of the multipliers. Yeah, same goes with the cross multipliers, like ax is greater than ay. You can go, so ax is greater than suppose by, and you cannot do like ax is greater than b by a into y unless you know that both of them are positive or both of them are negative, and based on that you switch the signs. So this is one of the important concept which actually on it becomes very uh, easy to neglect, because uh, what happens is it looks so straightforward and so easy to cancel both the sides, but actually we cannot. because if we do that, then it will again create problems of wrong inequality. Okay, this was our first concept. Let's go to our second concept. Okay, what happened to my pen? Right, this is the second concept. This says that the concept of number line is very useful in checking inequalities. The common values to check is 0, 1, minus 1, less than 1, preferred value greater than 1, preferred value equal to 2, between 0 and 1, preferred value is 1 by 2, 0.9, between minus 1 and 0, preferred value is minus 1, minus half, minus 0.9, and less than minus 1 is preferred value minus 2. So in short, there are 9 points, right? So what does this say? This say that whenever we want to check with different values, suppose there is one equation x plus y equal to z, right? And we want to check this equation with various values of suppose y to check whether it fits or not. So uh, the things that we want to check is always we have to cover the whole part. Basically, we have to make something that represents the whole number line. So if we are covered with those values, everything will be covered. First thing is zero. Always check with zero first. Once the zero is covered, then for the yes and no answer, basically in DS, we want it when we cannot put arbitrarily all the values, right? It will take a lot of time. So we have fixed some values, we can put those values. So between first of all, you put zero, then put one. So this covers the uh, zero, this covers the positive, then we get one negative, right? Now we get something that is greater than one. So we will always take two, and one for less than one, we will always take minus two. The other parts are the fractional parts. So we have to cover these fractional parts also because a lot of times these fractional parts will be having different properties than the actual. So for this fractional part, we always take either half, okay, either 1 by 2, or we might take 0.9, 0.9. These are the two values. Same on the other side, minus 0.9. So basically, if we see, we get 9 values, minus 2, minus 1, minus 0.9, minus 0.5, 1, sorry, 0, minus 0.5, this is 5, right? We had 5, yeah. Okay, sorry, this is plus, and 0.9, then 1 and 2. So 1, 2, 3, 4, and 1, 2, 3, 4, 5. This becomes 9 values. These are the 9 values we'll be using to check. So if we are given some equation when we want to get a yes and no answer, we'll check all these values. So we cover the negative, plus, decimal, fraction, everything. So this is the second concept. Basically, it is more to do, but this is very important things to remember. Basically, when solving DS, and when we go to a higher and higher uh, level of questions, it is more DS and less problem solving. So we need to do that. And next we can check is next question is if x minus y. Okay, let me take the one. This says if x minus a into x minus b is less than 0, then x lies between a and b. Yeah, so why does it happen like that? So basically these values, let us put some values to understand that. Okay, so what happens is if we take a and like x minus a is 1 and b is 2, x minus 2, right? If this is less than 0, how it can be less than 0? It has to be negative. How it can be negative? Suppose if x is 0, then this will become, sorry, if x is 1, right? Then it will become 0. So let's take x as 2, then also it will become 0. Weird. 0, 1, 2 is gone. So let's take 3, right? So 3 minus 2 will become 1. This will become positive. So again, this is not becoming 0. So basically, you are seeing, right? So I've taken all the values, but it is not coming in that range. So basically, I have to take something that is in between -1 and -2. Okay, sorry, here -2 and here -1. So let me take it. First of all, let me take -1. So -1 into -1 become -2. -1 into minus, this will again become positive, right? Because it will be minus into minus plus. So this we again we cannot take this also. So we can only take in these values. So what I can take, I will take -1.5. Okay, that is exactly in middle. So if that is the case, then -1.5. So this will become -1.5 minus 1, which will be -2.5, and into -1.5. I have done something wrong here. This is plus, because minus is also not coming correctly. So basically I have to take plus 1.5, because a and b are actually a is equal to 1 and b is equal to 2, not like a is equal to minus and b is equal to minus. Actually the equation itself is minus. So right. So in that case, what I will do is I will make this as mm, 1.5. So 1.5 minus 1 becomes zero point 0.5, and minus 1.5 minus 2 becomes minus zero point 0.5. Then this will become 1 by 4th, right? Mm, so this is less than 0, which is right. So only when it is in between 1 and 2, this will hold up. Actually, this is derived from the distance formula, but I don't want to discuss that. Oops. Right. So let's go to number 4. So number 4 is the same thing, x minus a, x minus b. Then this is greater than 0. That means this guy lies outside. So basically, if this is a and b, x will lie here, either here or here, anywhere, but it cannot lie on this. So it will satisfy all these. Again, here also you can put the value and see, but this will be x is less than a and this is greater than b. Okay, we don't need to spend much time on it. Let's take the fifth one, which says x square is greater than x. Okay, when x square is greater than x, then either x is greater than 1 or x is negative. Why do we say that? Because x square can be positive or negative, right? So x square is greater than x. If that is the case, then how we can solve it? Let's take one value, right? If what will be the value that can satisfy? Let's 0, no, 1, no, right? Minus 1 square is 1 again, and this no. So now we have to take a bigger value. Let's take 2. So 2 square is 4, greater than 2, right? So this satisfies. Let's take minus 2. Minus 2 square. Minus 2 square is 4, greater than minus 2, right? This satisfies. How about minus 1? Minus 1, okay. Minus 1 also satisfies, because minus 1 square is 1. 1 is greater than minus 1. Satisfies. Okay. So basically all the negative values satisfy. In the positive value, 1 doesn't satisfy, 0 doesn't satisfy. Let's take other values that we have. We have 0 0.5. Let's see 0 0.5. 0 0.5 square is equal to 1 by 4 and greater than 1 by 2. So this is not satisfying, right? So this also doesn't satisfy. Let's take minus 0 0.5. So minus 0 0.5 will be 1 by 4, greater than minus half. Yes, this satisfies. This satisfies. So all negative values are satisfying. On the positive value, uh, 0 is 0 is greater than 0 is also not satisfying. 0 doesn't satisfy, 1 doesn't satisfy, right? And 2 satisfies. And 1.1 square is greater than 1 also. 1.1 also will become 1.11 square, which will become 1.21. Is greater than 1.1. So this also satisfies. So after 1, everything satisfies basically. So 0 to 1 doesn't satisfy. So anything apart from 0 to 1 satisfies. 0, 1. So here, this is the range. So these are the negative numbers, and this is x is greater than 1. So you have to remember that x square is greater than x, then this is the range. You can should remember, or if you don't want to remember, don't want to remember, but yeah, this is very handy. It likes actually speeds up the calculations. Let's see number 6. Same happens when x is less than x, x square is less than x. What will happen here also? Things will satisfy, things will not satisfy, but the range will be 0 and 1 in between instead of uh, right. Okay, let's take number 7. Number 7 says x square is equal to x. Okay, this will happen only at 0 and 1, right? So these are the only two points because internal is covered, external was covered, but only when it is 0 and 1 it will be equal. Okay, right. Let's check number 8. Number 8 says x cube is greater than x. So x cube is greater than x. Either so this also same concept. We can put different values. What happens if we put 0? It starts with 0, doesn't satisfy. 1 doesn't satisfy. And minus 1. Minus 1 would be minus 1 greater than minus 1. Doesn't satisfy. Because that time it was making it square. Since it is cube, it will not even make, so doesn't satisfy. Let's try it to 2 cube is greater than 2. Satisfies. Let's try it minus 2. Minus 2 cube is greater than minus 2. Minus 2 cube is minus 8. Doesn't satisfy. Right? Got my point? I'm saying like minus 2 cube is greater than minus 2. Minus 2 cube is minus 8 greater than minus 2, which is not the thing. Okay? Right. Now let's try the decimal points, which will be 0.5. For 0.5 cube, it will become 1 by 8. Right? 1 by 8 is greater than 1 by 2. Is it? No. So it doesn't satisfy. So minus 0.5. Minus 0.5 will be minus 1 by 2 greater than minus 1 by 8. So minus 1 by 8 is greater than minus 1 by 2. No, right? This is correct. So this is satisfying. Yeah. And let's take the last one. Okay, so basically we can make number line here only. So we made minus 2 doesn't satisfy, minus 1 doesn't satisfy, minus 0.5 satisfies, 0 doesn't satisfy. So basically this range is satisfying, we can say, and 1 doesn't satisfy, right? 2 satisfies, 2 cube, right? So even 1.5 would satisfy. So greater than 1. So this is the range. Weird range, but it is like x is greater than 1 or x is between minus 0 and 1. This is correct. Or x is greater than 1. This is where x is greater than 1. Yeah, so this is what it is. So this says that uh, it says that either x lies in between 0 and minus 1 or x is greater than 1, right? Okay, this is number 8. Oops, what happens? Okay, Let's go for number 9. Number 9 is same, x cube is less than x. So basically whatever we got there, it will be opposite. So everything would be 0, minus 1, and 1. So it will be like this. So either x is less than minus 1, or x is in between. X belongs, we actually used to say like this, x belongs to 0, 0 to 1, something, right? Okay, let's go for number 10. Number 10 says x cube is equal to x, so that will, right, but how can this be possible? It is only when it is 0. X is equal to 0, x is equal to 1, right, and x is equal to minus 1. So these are the 3 points. Okay, the 10th number. Let's see what is the 11th one. 11th one says x is greater than y. It doesn't necessarily mean that x square is greater than y square, which is right. But yeah, it might be. Okay. I thought there is a eraser shortcut, but there is not. So I will just grab it. Right. Okay. So yeah, doesn't mean that x square is, how I'm saying is, suppose 0.5 is greater than 1. Sorry. Let me check it the other way. 0.5 is greater than 0.1, right? So x square would be 1 by 4, right? And 1 square will be 1 by 100. So now 1 by 4 is greater than 1 by 100. Is it true? Yes, that is true actually. So it's greater than x square is greater than y. Okay, so let's see square. Now if it was, it was 5 square, and like if it was x was 5 is oops, there is something wrong I'm doing. Well, I think the decimal should not follow this, but still, let me take the negative numbers and then I'll take decimal. Okay, so like minus 1 is greater than 0, minus 1 square, sorry, 0 is greater than minus 1, 0 square is 0 is greater than minus 1 square is 1, right? So this is, yeah, this one doesn't follow because, yeah, if suppose this is x, this is y, then x square and y square. So this doesn't follow, this follows, right? So yeah, that's what it says. Doesn't mean that, so even powers of the roots can't be predicted. Okay, and same thing it says for the 12th one. For the 12th one, it says that if x is greater than y, doesn't necessarily mean that x cube is greater than y cube, etc. Odd powers do not change the sign. Okay, sorry, it is necessarily true. Okay, so if x is greater than y, definitely this is okay. So even power cannot be predicted, and odd powers don't change signs, so it can be always predicted. Okay, fine. Right. Let's check the next one, which is number 13th. It says that AB is greater than 0, it means A by B is greater than 0, and vice versa. Okay, so right. So if AB is greater than 0, A by B is greater than 0, uh, here and B both are of same sign. So suppose I have 2 by 3 greater than 0, then 2 into 3 also greater than 0. Basically, yeah, it would be having same sign, then it is possible. What happens if they have opposite sign? That is, I think, the next one, yeah. So if AB is less than 0, that would mean this basically these are whenever there's a less than 0 sign and two are multiplying, they have opposite sign. So this is the thing. This is just saying that they have opposite signs. Okay, this is like telling that one of them is negative. Okay, so if one of them is negative, then either A is negative or B negative, then A by B also will be negative, right? If it is like one minus one into two is less than, so then minus one by two also will be less than zero. Okay, that was easy. Let's see the last one, and then we'll start problems. So the last one says if x is positive, then a plus x divided by b plus x is greater than a by b. Okay, this happens only if a is less than b, and if a is greater than b, then it is a plus x divided by b plus x less than a by b. Okay, this is a very big long shot to remember. Want to remember, you remember. Don't want to remember, you don't remember. But if a is less than b, basically whatever you add to a by b. So like if you have some kind of equation where you're adding a constant, then the addition of the constant will actually increase the value of the fraction. But if a is greater than b, where the numerator is actually greater than, then adding some extra constant value will reduce the value of the fraction. Okay, so we'll continue in the next discussion.